Hello students, in this video we'll discuss a derivation of the arc length formula for a parametric curve. If we're given x is a function f of t and y is a function g of t for t between a and b, we have our parametric curve over here. I'd like to find the length of arc between from the starting point to the terminal point. So what we're going to do is we're going to sketch our curve over here. So here we go. Here's the x-axis, here's the y-axis, and the curve may do something like this, like so. So this would be, of course, the point f of a, g of a, and this would be the point f of b, g of b, at my terminal point. So what I can do then is what I'm going to do, I'm going to take the time axis, I'm going to partition the time axis. So partition AB. Now how do I do that? Well, here's A, here's B, and I equally partition it like so. So I define TK to be what? So I define TK to be A plus K times B minus A over N. So in other words, what I do is I say this is going to be A, this is going to be A plus 1 over N, A plus 2 over N, A plus 3 over N, all the way down to A plus K times B minus A over N, of course, B minus A. And then plus K, B minus A, the total length over N. So I equally space the partition over here, and I find these points TK. So that's my point TK. And of course, these points TK are going to be mapped onto the curve over here. So these points TK are mapped onto the curve, like so. Like so. And what I'm going to do is I'm going to compute the distance from the point f of tk, g of tk to the next one, right? So this point over here would be, what would this point over here be? This would be f of tk, comma, g of tk. This point over here would be what? This point over here would be f of tk minus 1, g of tk minus 1, okay? And so to find the distance between every two pair of subsequent points, that will give me a what? If I compute all those distances and add them up, that will give me an approximation of my what? Of my arc length. So I'm going to compute all those little distances over there, all the distance between points. So what is the distance between those 2 points? So the distance between what? Between f of tk minus 1, g of tk minus 1, and f of tk, g of tk, using our distance formula, is going to be what? It's going to be the square root of the difference in the x's squared, f of tk minus f of tk minus 1 squared, plus g of tk minus g of tk minus 1 squared. So that's a typical distance. And now here comes the formalism part. If I have the distance, we want to recall a major result in calculus. Let's recall the mean value theorem, which says what? It says that f of b minus f of a is f prime of c times b minus a, for some c in between a and b. So here c lies between a and b. So in between all of these points tk, I can find a new point. I find a whole bunch of new points by the mean value theorem. I apply the mean value theorem for all of these intervals, and I see what this is equal to. Is this can be simplified to what now? So by the mean value theorem, this is equal to what? By the mean value theorem, this is equal to the square root of f prime of, let's say, tk star times tk minus 1, quantity squared, plus what? Plus g prime of another point, tk, maybe star, because it could be a different point by the mean value theorem, times what? Times tk minus 1 squared. And now the main point of this is that they both have a common factor of tk minus 1, so I'm going to factor that out. So this is going to be what? It's going to be tk minus 1 times this square root over here, times f prime of tk star squared plus g prime of tk double star squared. Now if I add all of these up, that'll be my approximation. So the length is approximately what? So our length is approximately the sum, j goes from 1 to n, of this square root over here, f of tk star squared plus g of tk double star squared with a prime and a prime, of course, right? Those are derivatives. And then times the quantity tk. And that's, I'm going to turn that, that's a j I've written, but it should really be a k. That's my index of summation over here. So let's turn that into a k. It's really k. K goes from 1 to n. tk minus 1. Okay? And now this is exactly a Riemann sum, right? So as n goes to infinity, if this limit converges as n goes to infinity, the length will actually be equal to what? This is my function over here. It's going to be the integral from a to b of the square root of f prime of t squared plus what? Plus g prime of t squared dt. So if that limit exists, in other words, if this function over here is integrable, then the limit as n goes to infinity will converge, and this will be the arc length formula. We can also write this in what form? We could also write this f prime of t as just dx dt, and we could write this g prime of t as dy dt. You see both notations written throughout different textbooks. But this, when this limit converges, will give you the arc length of the curve between a and b as the parameter. Thank you very much.